Number 22, caffeine is a weak base with a Kb value of 4 times 10 to the negative 4. So that's a pretty low Kb value. The pH of a 0.01 molarity solution of the caffeine is in the range of. Well, first of all, before you guys actually even do this question, please immediately get rid of A and B because we are talking about weak base. I understand this is a weak base, but it's still base. So there's no way in hell the overall pH is going to be something acidic unless we have some like acidic compounds in there, which the question never really talks about. So it has to be in the basic range. So I'm probably not even going to think about that choice C because 7 to 8 is quite neutral, right? So if I only have like 5 seconds left and I have absolutely no time to do this problem, I'll probably just circle D and move on, which in this case the answer is D, but just know that, you know, logically speaking, A and B are just completely out of the picture and C is most likely to be out of picture too. So let's actually do it the right way using the ICE table. So we have C8H10N4O2. You dip that in water, and that's going to pick up one of the H plus because that's what Bronsted-Lowry base does, right? CHH11N4O2 plus, and then the OH minus hydroxide. So let's create the ICE charts. Initially, I have 0.01 here. I have, well, this is water, so you don't have to worry about it. I have nothing. I'm going to lose, I'm going to gain, I'm going to gain. So that'll be 0.01 minus x, x, and x. Now, notice this is a weak base. Kb value sucks, which means the whole losing x part, that's probably going to be very, very trivial. So little to the point that we can probably ignore it. So you can just drop that. So we're going to go ahead and set it up. X squared over 0.01 is equal to 4 times 10 to the negative 4. So x squared is equal to, well, call that 10 to the negative 2. So multiply by 10 to the negative 2 on both sides. And that should be 4 times 10 to the negative 6. So square roots, and x is equal to 2 times 10 to the negative 3. So that is what the OH minus concentration would be, right? So 2 times 10 to the negative 3. So in order to calculate the pOH, sorry, I'm just jumping around, that would be negative log of the OH minus concentrations. So that would be negative log of 2 times 10 to the negative third, which is going to be something like 2 point whatever, right? So remember, pH and pOH, let me just kind of go up here, pH plus pOH should add up to 14, of which I know the pOH is like 2 point, I don't know, man, like let me just say like 2.8 or something. It really doesn't matter. Whatever this pH is, and that's equal to 14. So if you subtract 2.8 on both sides, pH is going to be about 11.2 according to my calculation. Once again, it's not probably like super exact, but something like 11 or something. And that basically confirms my answer. It's going to be choice D, anywhere from 11 to 12.